Hello everyone. Today, we in the team Mental Health Mavericks are excited to present our project titled as AI for Emotional Well-being, designing an NLP-based mental health chatbot. Meet my team members Uma, Raimil, Sonal, Jarana and myself Abarna. As we all know that mental health is a critical aspect of our overall health, yet many individuals face significant challenges in accessing adequate mental health services. This can be due to various factors such as stigma, lack of resources, or geographical barriers. To address this pressing issue, our project aims to develop an AI-based chatbot designed to provide reliable and empathetic emotional support. Our chatbot focuses on five primary mental health issues: anxiety, schizophrenia, post traumatic stress disorder or PTSD, depression, and phobia. Using advanced machine learning techniques such as neural networks and stochastic gradient descent, we strive to create a chatbot that can understand and respond to user inputs with empathy and accuracy. Our vision is to make mental health support more accessible and immediate, offering a lifeline to those in need right at their fingertips. By harnessing the power of AI, we hope to make a meaningful difference in the lives of individuals facing mental health challenges.
Our primary research question is based on how effective is an NLP-based chatbot in providing emotional support and enhancing mental well-being. So we aim to evaluate the impact of the chatbot interaction on users' mental health outcomes, such as reducing the feeling of loneliness, anxiety, and depression. Additionally, we are investigating specific NLP techniques including contraction correction, spelling correction, and handling stoppwords. So, to understand how these pre-processing steps affect engagement and satisfaction by making conversation that are more fluent and natural. So, lastly, we explore the chatbot's ability to generate odd variants and its influence on the relevance and accuracy of the response, which is essential for maintaining meaningful and contextually uh, appropriate interaction with users. So, let's dive into the hypothesis. Our hypothesis is that an NLP based chatbot will significantly improve emotional well being by providing a scalable and accessible solution for mental health support. So, we expect that user will report improvement in mood and a sense of connection after interacting with our chatbot. The second hypothesis suggests that the chatbot ability to correct language input, such as contraction and spelling error, will enhance the user experience by making the interaction smoother and more comprehensive. Throughout this, the main focus is in increasing user engagement and satisfaction. So, our third hypothesis anticipates that generating old variants will improve the chatbot responses, making them more relevant and accurate. This enhanced response quality is expected to provide better support to users by addressing their concerns more effectively. So, these hypotheses will guide our investigation into the chatbot's effectiveness and efficiency in a real-world setting, aiming to validate its potential as a tool for mental health support. So, thank you all for the listening. Now, I will like to hand it over to the Sonal to discuss our methodology in detail.
The dataset for this project was sourced from publicly accessible datasets and online mental health forums. This diverse collection of data ensured that the chatbot could handle a variety of user queries and mental health issues. Data cleaning involved expanding contractions such as can to cannot, isn't to is not, and so on, correcting spelling errors using a spell checker algorithm, and removing stop words and punctuations to highlight essential content. Word variations such as plurals, singulars, and verb forms were generated to improve the chatbot's comprehension and response capabilities. Text data was converted into numerical representations using the bag of word method. This approach involved creating unique vectors for each word with binary values indicating the presence or absence of a word in a given text. The chatbot model consisted of three layers. The first layer with 128 neurons, the second layer with 64 neurons, and an output layer with neurons equal to the number of intents. The model used ReLU activation for hidden layers and softmax activation for the output layer. The model was compiled using stochastic gradient descent with Nesterov accelerated gradient to optimize the categorical cross entropy loss.
Talking with someone can help you express yourself and see life from different perspectives. This is beneficial for mental health, as demonstrated by Chantal McAllister and Hogan in their study about understanding mental health patients. The experience of being understood significantly increases self-understanding. This insight drives our commitment to provide users with seamless experience when interacting with our chatbot. We focus on addressing five main mental health issues: anxiety, depression, phobia, schizophrenia, and PTSD, along with the initial and emotional questions. This approach resulted in accuracy of 99% on the train set and 86% on our test set. With that said, we have designed and developed a final product, a web page that anyone can access and get help instantly. The responses provided have been revised and corrected to not harm anyone. By leveraging such high accuracy, we aim to offer meaningful conversation that can aid in mental health support and understanding, with the understanding that an increase in this result will indicate better responses, almost like human responses. Nowadays, conversational agents appear to be feasible, engaging in effective way. This means that chatbots can provide accessible, immediate, and practical support for individuals that experiences mental health challenges, complementing traditional therapy methods and expanding access to care.
Yes, in conclusion, we have achieved an accuracy of 86.04%, precision of 85.44%, recall of 86.04% again, F1 score of 85.21%. Our project showcases the transformative potential of artificial intelligence in providing accessible and immediate support for mental well being. The chatbot offers real time interaction and empathetic responses, ensuring that the users feel heard and supported. As we look into the future, we have identified several areas for improvement and expansion. Enhanced personalization. We aim to further refine the chatbot's ability to deliver highly personalized responses by incorporating more advanced machine learning techniques and expanding our data sets. Collaboration with mental health professionals. Strengthening partnerships with mental health professionals and organizations will ensure that the chatbot remains informed by the latest research and best practices in the field. Last but not the least, Google API integration for health support. By integrating Google APIs such as Google Maps and Places APIs, the chatbot can help users locate nearby mental health services, clinics, and support groups. This integration will provide users with real time information on available resources, including directions, contact details, and reviews, ensuring they can access the help they need quickly and conveniently. This project underscores the importance of integrating technology with mental health care to create a more inclusive and supportive environment. As we look into the future, our focus will be on expanding the chatbot's reach, improving its functionality, and ensuring it remains a reliable, empathetic resource for those seeking mental health support. Ultimately, our mental health chatbot project is a step toward a future where mental health care is more accessible, personalized, and stigma free. We believe that With continued innovation and dedication, technology can play a pivotal role in improving mental health outcomes and fostering a healthier society. Thank you for the opportunity. This is Team Mental Health Mavericks.